These are our solutions for Can You Do 64. For the first 2 pages, I don't think that I really need to walk you guys through the solutions. You can see the work that I went through. So you can just pause and double check if you would like to on these problems. On part B, make sure that you did address by how much the 2 samples differ. So make sure that somewhere you have the difference. And then on 45, this is my work. 46, this is my work. Okay, so one thing that I wanted to mention when it comes to these sample size problems. You can see in this one that I cut the work down quite a bit, and in the review, when I go through the review problems for this unit, when I calculate needed sample size, I usually just write it like this because I've done it so many times that I know where all the numbers end up. So that being said, you should show as much work as you need to show. Do not use this shortcut if you do not have that memorized. That will be a huge disservice to you in the end. So if it's easier for you, then you just do it one step at a time. And if it's if you've done it so many times that you know it, feel free to use this shortcut. So the ones that I wanted to explicitly go over start on number 47. Okay, so teens and their TV sets, that's what this is about. According to a Gallup poll, 64% of teens aged 13 to 17 have TVs in their rooms, and here is the footnote for the report. These results are based on telephone interviews with a randomly selected national sample of 1,028 teenagers in the Gallup poll. For results based on this sample, one can say that the maximum error attributable to sampling and other random effects is 3 percentage points. In addition to sampling error, question wording and practical difficulties in conducting surveys can introduce error or bias into findings of public opinion polls. So let's pull out the information that we might need. This guy, 64, would be our p-hat. They give us our sample size of 1,028. And then they tell us that our margin of error is 3 percentage points. So that means margin of error is 0.03. We omitted the confidence level from this footnote. Use what you have learned to determine the confidence level, assuming that the Gallup people took an SRS. Okay, so for margin of error, I'm assuming that what they want us to look at is that the margin of error equals my z critical times my standard error of p hat. Okay, well this I know. This is 0.03. And this I can calculate. What our confidence level contributes to this equation is the z critical value. So this critical value comes from your confidence level. So if we find the critical value, we can use that to find the confidence level. So I'm going to fill in these pieces of information. 0.03 equals z critical times 0.64 times 0.36 all over 1,028. To solve this equation, all we need to do then is divide this to the other side. So I'm going to divide my margin of error by this big radical. And I personally just leave it in the radical so that I can get as close to possible as the true value. So I am taking my margin of error and dividing it by my standard error. That's going to give me my critical value. I plug this into my calculator exactly like that. So let me get out of my graph. I'm going to hit the fraction button. So that's alpha y equals, and then you choose option 1. In the top, I have 0.03. Arrow down, blue button, x squared button to get your root, green button, y equals to get your fraction, 0.64 times 0.36, all divided by 1028. This gives me a critical value of 2.004. So then I go to my pink table, the bottom row, and I find the one that's closest to 2.004. I'm just double checking my answer. So this one is a little bit bigger, 2.054. This is 2.004. So I'm going to use the confidence level below this one. So I'm going to use a 95% confidence level. So I'm not using this one because it's too big. So I'm going to use 95%. We think that this was a 95% confidence level. In the footnote, it says, in addition to sampling error, question wording, and practical difficulties, in addition to sampling error, question wording, and practical difficulties in conducting surveys, can introduce error or bias into finding of public opinion polls. So I think that I read that weirdly, but essentially what they're saying is, in addition to regular sampling error, we can have errors due to question wording and practical difficulties. So down here it says, give an example of a practical difficulty that could lead to a biased result for this survey. Well, what your book has here is that teenagers might be hard to reach or unwilling to participate. So what your book has is that teens might be hard to reach or unwilling to participate. Okay, number 49 is alpha. I'm just double checking the phrasing. So the poll found that 28% of American adults expect to inherit money or valuable possessions from a relative. The poll's margin of error is plus or minus 3 percentage points. So that means that our confidence interval is 25 to 31. So this margin of error, we combine with that 0.28. So 0.28 plus or minus 0.03. This means that the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. That sounds right to me. The percent of adults who expect an inheritance is between 25 and 31. No, we can't make that statement because we're not 100% sure. If Gallup takes another poll on this issue, the results of the second poll will lie between 25 and 31. Well, they would have to take another poll with the same exact sample size, and even in that case, 5% of those samples will not probably be within that, could not potentially be within that interval. There's a 95% chance that the percent of all adults who expect an inheritance is between 25 and 31. No. We don't really word our confidence interval based off of a probability or saying like there's a 95% chance. That's the same as saying there's a 95% probability. We don't really interpret confidence intervals that way. We don't interpret them as a probability. We say how confident we are, like this one. Gallup can be 95% confident that between 25 and 31 of the sample expect an inheritance. No, the sample was 28. So that doesn't even make sense. We're 95% confident that between 25% and 31% of the sample expect an inheritance. No, we're 100% sure that it was 0.28. 28% expect an inheritance. So A as in alpha is the correct answer. There is really no tried and true method to figure out which of these statements is right. And to help with that, in your review for this unit, I tried to give you as many problems as I could find that were related to interpreting an interval, interpreting a confidence level, or determining what statement about the confidence interval is true. The reason why I want to give you so many is because there is no algorithm, there is no list of steps or phrase to memorize that can help you get these right every single time. You just have to have a really deep understanding of what a confidence interval is really telling you. Okay, so next page. The margin of error for a 95% confidence interval for the true proportion of tongue rollers is closest to. So margin of error is Z critical multiplied by standard error of P hat. And your P hat is 317 out of 400, or 7925. So if you combine your Z critical for 95%, that's 1.96, and plug this into your standard error formula, you will get D as in delta. D as in delta. 51, you want to design a study to estimate the proportion of students at your school who agree with the statement. The minimum sample size required is C as in Charlie. So if I show you the work for those two, that's the amount of work that I have shown for number 50 and 51. And then lastly, wants us to find, 52 wants us to find the confidence level. Capital C is your confidence level. Well, luckily, we just did one of these. And what I realized in doing this is that anytime I want to find the confidence level, I can take my margin of error and divide it by my standard error. If you want to know your confidence level, you can use this formula every time. Margin of error divided by standard error. If you want to just use this formula and solve the equation every single time, that's fine, but I'm going to use this as a shortcut. So on this problem, we have an SRS of 100, so that's N. The proportion of all residents in the city who approve of the mayor's job performance is given in the interval. And one thing to notice is that you are dealing with a proportion. They explicitly tell you proportion. Okay, well, in order to use my margin of error formula to find C, sorry, let me rewrite that. Oh, sorry, that's not C, that's Z critical. So on this formula, this is not C. This is Z critical. And then you use your Z critical to go and get C. I'm sorry about that, I apologize. Okay, so back to this problem. Z critical is equal to our margin of error over our standard error. Okay, well, I know then that I need to know my margin of error, and I have a formula for that, luckily. It's your upper bound, subtract your lower bound, divided by 2. That's from lesson 61. So 0.695 subtract 565 divided by 2 gives us a p hat of 63. Oh, I like. Gives us a margin of error of 0.065. So our margin of error is 6.5%. To calculate the standard error of p hat, I know that I need to know what p hat is. Well, p hat is your point estimate, and we also have a formula for that. It's your lower bound plus your upper bound divided by 2. So lower bound 565 plus upper bound 695 all over 2. Plug that in, and that gives you a p hat of 0.63. So now to find Z critical, margin of error is 0.065 over big root 0.63 times 0.37 divided by 100. Plug that all in, and we get a Z critical of 1.35. So I go to my table, and I'm looking for the one closest to 135. So it's somewhere between 80 and 90. You want to go with the lower one. So we're going to choose an 80% confidence level. So what are my options? 82, 86, 90, 95, 99. So what is the value of C? I'm going to go with 82. You always want to go with the one below. So, or the lowest one. So that's why I'm choosing 82 as opposed to 86. 82 is closest to 80 as I can get. Okay, that's it. Because this is the last lesson in this unit, it is imperative that you ask questions if you are confused about any of these calculations. And I have tried to include many opportunities for you to practice finding the things that we've learned in this lesson. So finding sample size, but also finding margin of error, or finding the z-critical to find the confidence level. So I think that this review does a very good job of exposing you enough times to the type of problems that you'll see. So hopefully that's reflected in your test results. So yeah, if you have any questions, please get the help that you need. I'm happy to help you. Okay, that's it. Love you guys.